Hey gang, happy Tuesday. Sorry I missed you earlier today. We've got a couple things to work on this week. The chapter 5, we're moving right on into here. We're going to do this for today, Tuesday, and then Thursday. Then we'll come back on Monday for a lab here on loops. We'll get through probably about half the chapter or so today, and I'll save the rest of it. We'll probably get to the maybe 5.7, maybe 5.8, and we'll pick up the rest of it when we come back on Thursday here. So the main idea here with the loop is that we want to be able to do something more than once in our code. Right? If you had a chance to start that lab, we're having some random numbers and having the user guess. So we start off with some, we'll call it like the magic number is a random randint from, 1 to 100 or something. Oops, but we need to import random, don't we? So we're going to import random. I think I showed you guys this last week, right? So we can get a random number here, and then we want someone to guess, right? So we're going to have a guess is an int of an input of guess a number. So number from 1 to 100, and then we'll tell them if it's too high, too low, or what. Right? Oh, I'm missing a parenthesis. There we go. So you can check. So if guess is less than the magic number, we'll print too low, right? Else if the guess is greater than the magic number, we'll print too high. And just a last else here, right? We don't really need anything else because we don't need another if. If it's not too low and it's not too high, it's got to match. We'll print, you guessed it. You guessed it. This sort of thing. And if we had to do this 5 times, it'd be a little bit annoying. You probably had to copy paste a bunch. So I guess 50, we're too high, and we're done. And I don't want to have to copy paste this in 5 times, right? And ask them to guess 5 different times. And then if they did guess it right, are we still asking them over and over and over? So you can get irritating pretty quick. So what we get to do is we can take a Boolean expression, something like this. Guess is less than magic number, or guess is greater than magic number, or in our case, like if we did is equal to magic number, and we can make the code run again and again and again and again. And it's fantastic. So what we can do, we use this while loop. We're going to say while guess does not equal magic number. And there's a whole bunch of operators we can use, right? These are our relational operators, right? Greater than, less than, anything here. As long as this becomes a true or false statement, just like an if. As long as it's a true or false statement, you can stick it in the expression. So we're saying as long as it's not the magic number, we're going to make them guess. And all we have here is it's either too high or too low, and then we want them to guess again, right? So we'll say guess. We'll just copy that in, right? Whether or not it was too high or too low doesn't matter. We're going to make them guess again. And really, this could probably be an else at this point, because I'm only what happens with a while loop is it's only going to run if this is not true. I'm sorry, if this is true. So it says if this is true, so if they're not the magic number, if it's less than, print too low, otherwise it must be too high. We'll make them guess again, and then this actually should come back down one. When this becomes false, the loop will stop running. So the loop, it will check. If it's true, it runs to the bottom, everything that's indented here, and then it comes back up and checks again. It says, hey, is this true? If it's true, it runs again. So it's running while this expression is true. So what we're doing here is we're saying as soon as it doesn't match, as soon as it does match, this will become false, right? If guess does equal magic number, not equals is false, and a false will trigger the while loop to stop when it evaluates, and then we'll print out that they guessed it. Great, so all we have to do here, and we can run this guy. And we'll guess, all right, 50 is too high, so we'll guess 25, too low, so like 37 or so, right? Just keep splitting the difference. I don't know, 32, I forget all the math here. 28, too low, maybe 30, too high, 29. We guessed it. Look at that. So it just let us guess every time. So maybe we should have added like a colon and a space, make this look a little prettier. Make it something we're proud of here. The main idea here is that you want to make sure that what is being evaluated in the expression here will eventually become false. Because otherwise we're going to have an infinite loop. And you don't want an infinite loop because that means we're going to be stuck here forever. So make sure whatever you're checking here is going to be changing so that eventually maybe it will become false and we can stop. Because if it's only ever true, then we're just stuck forever. And then that's no fun. So it's a quick little way here we can just make the code run over and over and over again without having to copy paste any code, which is good. Anytime you've got repeated code, you should feel bad about yourself. So this puts us in a pretty good state here with our guessing game. Now, this is pretty easy, right? You can guess as many times as you want. right? Over and over and over. So what if we gave them some max number of guesses? Should we do something like that? We could say, max guesses is, I don't know, maybe 10 guesses. And then we'll have current guesses, or number of guesses maybe. Number of guesses equals 1, because they guessed the first time here. And what we're going to do is we get to use some of those logical operators. We can use the and, the or the not, that operate logically. So we want to say, as long as we're not the magic number, and the number of guesses is less than or equal to 10, because at guess number 10, we want this to run. When we come back with guess number 11, we don't want it to run. Right? So this will keep them in the loop as long as they don't have it and they're less than 10 guesses. When we're anding, right, with the logical ands here, if either one of them is false, the whole thing is false. So if it's not the magic number and it's less than or equal to 10, we're okay to be true. If this becomes false because it is the magic number, or this becomes false because we've guessed more than 10 times, the whole thing will be false and the while loop will stop. So one last time we need to check, right? So we need to say if guess is equal to the magic number, then we can print out they got it. Otherwise, we'll print out, I don't know, you took too many guesses, or you lose, the number was, and then we'll just print it in here, magic number. Oops, magic number. Use the right autocomplete. Okay? Well, the last thing we need to do, right, we're never changing the number of guesses. So inside of here, let's take number of guesses plus equals 1. Let's add 1 to it each time. Right, now let's see. So I'm just going to guess, 1, 1, 1. That's 5 guesses, 6 guesses, 7 guesses, 8 guesses, 9 guesses, 10 guesses. Oops, 11 guesses. Oops, we got too many guesses. That was 1. Well, this became 2. So we want less than 10, because this will be the 9th guess. They guessed the 10th time, the loop stops, and they either got it or not. Okay, let's try that. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and we stopped. We lost. The number was 37. Right, so we can use that while loop to repeat, and we can have any sort of expression in here, right? As long as it's eventually a true or false, we're good to go. So we just need to make sure that whatever we're putting in there is going to change and has a chance to become false. We don't have an infinite loop. And there's a lot of cool things you can do with these loops, right? This is just one particular case here. Another fun loop that's often used is something that's called like a sentinel value. So we're going to loop asking for some input, and the only way we're going to know when to stop is if they give us a funny value, or that sentinel value that is not normal. So like if I were to say I want to figure out the average score for the class, right, we could do something like that. So we're going to we'll output, say print enter score. Let's run some statistics, but I want to get it from the user. I don't want to have all of my scores here. So enter a score for I don't know, project 1, and I'm going to say or -1 to stop. So -1 should never be a valid score. 0 is probably a possible score. If you don't turn it in, you're going to get a 0 on the project. Right? At least turn in something, you can get some points there. So the -1 is my sentinel value here. So that's going to trigger my loop to stop. So I'm going to say score is equal to an int of an input of, oops, that should be here. Oh, sorry, we don't even have to print that. Let's just stick all that in here. Enter a score, and we're going to say while score does not equal -1, let's keep on going. So now I have a total score is going to start off at 0, and I'm going to have a number of scores equals 0. And inside my loop, if I get one, my number of scores, add 1, and my total score will add the score. And then we're going to ask them again. So we ask them, as long as it's not -1. If they gave me a score, this will be true, because it's not -1. I've added the score, and I'm added to its total, and ask them for another one. Then we go back to the top. The loop evaluates. If it's not -1, I just got another score, let's add it to the total. On and on and on, and then we're done. Right? So eventually, they can enter a -1. So then we can print out the average. The average score is, and we'll just do that arithmetic, right? We'll take the total score divided by the number of scores. Oops, number of scores. There we go. And that should give us a nice average here. We'll get a comma separate that. And there's lots of ways to do averages, but what this lets me do here I'll just guess a number. 75, this is too fun. 67, 61, 58, too high, 57, 56, 55. Oh man, I did that wrong. That's okay. Okay, so we guessed it, 55, cool. All right, so we're gonna enter scores. So we'll say, hey, we had 100, and a 90, and an 80, and then a 90, and then 100 again. And then -1 to stop. So it says the average here is 92. Let's check it, right? Let's go to your calculator, let's add them together. It should be 5 scores, so 100 plus 90 plus 80 plus 90 plus 100 divided by 5, 92. So look at that, Python can do math for us. It's always good to check it, right? Any code that's worth writing is worth testing. And we want to test to make sure it does the right thing. So this loop here is using that sentinel value. It's going to keep running until we get that particular value that means something. And we just get to enter things. So there's lots of good examples you can do in the book. There's some other fun loops they go through, like the greatest common denominator. That's a fun loop. There's more examples, counting. All right, so those are the basic while loops. Now we're going to look at the for loop here. A for loop is really good for going over a particular set of values, whether or not it's a tuple or a dictionary or a list or even like a string here. So we can say, let's also some sentence is equal to an input, and I want this as a string, so it's not an integer, right? It's just an input. So enter a sentence, and I'll count the vowels. Okay, just for fun here, and then we're going to use a little trick here in a second. So what I want to do, I want to say for letter in sentence. Now the variable letter here, this is not magic, right? It does not have to be letter. It could be A, but A is a terrible variable name, right? So it's saying for every item in this collection. So it's for item in some collection. The sentence here is a string. That's just a collection of letters. So I'm going to say for letter in sentence. Some people put C. I much prefer good variable names here. So I'm going to get each letter at a time. And then what I want to do is I want to see if it's a vowel. Now we got a trick for this. So I'm going to make a list here. I'm going to call it vowels, and I'm just going to put in here A, E, I, and O, and U. Okay, so those are the vowels here. Okay, and then we can use that membership operator. Remember, we can say if letter is in vowels, if I can spell it right, vowels, if it's there. Right, so I'm probably going to, a number of vowels, something I'm going to count in, start off at 0. And if the letter, now really I want the letter as lowercase, or I'm sorry, uppercase, right? So I'm going to uppercase the letter. I could also add all the lowercase vowels. Either way is perfectly fine. Or add lowercase as well. Upper if your list only has uppercase letters. Either way is perfectly fine. Whichever way you want to go about it. I'm just going to uppercase each letter and then check the uppercase list. Doesn't matter too much. So if there's a vowel, my number of vowels will go plus equals 1. And that's all I do. There's no else. There's nothing else I need to worry about. And I'm done. I'm going to print our sentence has number of vowels. Let's test it, right? Let's give that a run. So 50, too low 75, too low 87 or so, too low 94, too high maybe 90, too low 92, too high 91. Yes, we guessed it. Okay, scores. We'll just do -1. Oh, divided by 0. I crashed it. If you divide by 0, you get bad results. That's a mistake. So we definitely can't do that. Sorry about that. Let's try it again. 50. Oh, look at that. We guessed it right away. Lucky us. So we'll do 1 and then -1. Okay, average was 1. So let's enter a sentence. So how about the quick brown fox jumped over the lazy dog? Lazy dog. Can't type. 12 vowels. So an E, a U, and I. That's 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I counted 12 vowels. Look at that. Cool. So a for loop can go over each item in a collection. So if we had, say, let's do this. So let's take that scores here. Let's make a list of scores. So let's say the scores list here's an empty list, and every time you enter a score, I'm going to take the scores list and append that score. Remember, with a list, you can call append to add something to it. So what's even handier about this too is I don't need to do either of these. If I'm using my append here, I'm just going to comment those out. If I'm just adding them to a list here, don't need total score or total number of scores. I can take the sum of scores. Remember, you can sum a list real quick, and to figure out how many are in it, you can take the length of that list. So the sum divided by the length will give me the average. It's a nice little shortcut there. Then what I can do, I can say for score in scores, something. So for item in collection. So this is the collection, that's the list here. I'm going to do something for each item in it. And what I'm going to do is I'm going to track the high score is 0, low score is 100. So what I'm doing here is I'm starting these off as the opposite range. And we're going to look at every score and we're going to see if we can find a new high score. Okay, so for each score, we're going to say if score is greater than the high score, we have a new high score. High score is equal to the score. If the score is less than the low score, we have a new low score. Okay, so I know 100 is probably the highest, and I know 0 is probably the lowest. I mean, we can start these off as like ridiculously large numbers too if we wanted, but anything like that's probably fine. Because I know that your score is probably between 0 and 100. It's just a percentage here. And then we can print when we're done. So the high score was, let's do these formatted strings, right? Because those are fantastic. High score, and the low score was low score. Okay, or maybe highest. We should say highest and lowest. Okay, let's see that. So we'll just guess some numbers. 25, 37, right? You're going to get good at this eventually. 42, 46. All right, cool. 1, 2, 3, 4, 5, and 100. And sure, that's probably fine. -1. So our average, sure, enter a sentence, we'll count the vowels, just some gibberish. The highest score is 100. The lowest score is 100. Uh-oh. Oh, I didn't actually set low score. I just said low score. Low score equals score. That might fix it. Try it again. All right, 50, 25. Oh, too high. Wow, 12. Too high. 6. Too low. So maybe like 10. Too high. 8. Too high. 7. Gotta be 7. All right, we guessed it. So we'll enter some scores. So how about, let's do like 97 and 92 and 57 and 75 and 99 and -1 to stop. So average is 84. Enter some vowels. High score is 99. Low score is 57. So as we're going for item in list, we can do something with that item. Now, what you might be tempted to try here is once we know what the high score is, do this funny thing that everyone always asks for, which is what you ask for is a curve. And hopefully all of you are savvy enough at math and realize that some sort of curve, like a normal distribution is not what you actually want, right? Because this particular curve here in a normal distribution, wow, those are some funny looking ones here, but that's, right, they have the bulk in the middle. That does not mean the middle, the most common is an A, right? That would be this lower end here. That's a terrible normal distribution. Can I find like a decent one here? Normal distribution, I don't normal distribution curve, don't I? Yeah, that's the, like this, right? Why is that so hard to find? Right, where you get 68% or so of the scores within 1 standard deviation of the mean. Wow, it's been too long since I've done that. Tell me in Discord which one it is, because or maybe I'll have to Google it. Right, so we don't want this last little tail end here to be the A, right? You don't want a curve where most of you are less than the high score, right? So what most people ask for is they want a bump. They want the 100, I don't know what this is, the grade adjustment, score adjustment. Adjustment is equal to the 100 minus the high score. That's what most people want. They want to say, hey, if the high score only got 97, everyone should get those same 3 points. And you say for score in scores, score plus equals score adjustment, right? You want something like that. And then we want to print scores. that's the scores list. So let's do this. We'll print it before, we'll print it after we add that adjustment. Like, that's what most people want, right? If you can't get good enough, you know, if the best score wasn't perfect, a lot of people say, well, you know, make up the difference here. Wow, another low number again. 9, 8, 7. Okay, so let's enter some scores. So let's do like 95, a 96, an 85, a 92, and that's enough to stop for now. All right, so our top score there was 96. And then some letters here. So here were scores, right? We printed out 95, 96, 85, 92. We figured out that score adjustment, and we went and added the score adjustment, but the list didn't change. What happens with the for loop is this value here is a copy. So as we change it, it changes a copy, not the original list. So this is bad. You want to change the original. Okay? So what we have to do, original, am I spelling it the wrong way? Original. Okay. So what you actually want to do is this next thing, you want to use this range function. Range is the function here. So what we want to say is we want to get at things by index. Remember when we accessed items by index, we could say, hey, give me the character at index 2 or the value at this index. So we can say for index in range, length of scores. And this is kind of ridiculous here. But what range does is it generates a range of values, starting at 0 by default, and going up to but not including the number you give it. And that's really important, and it works out really well for you because the length of scores is the number of scores that are in there, and you have indexes 0 up to but not including the length. So if you have 4 scores, you have indexes 0, 1, 2, and 3. You don't have an index 4. So range of length of scores will give me a 0, a 1, a 2, and a 3. And I can say for index in range or for value in range. A lot of people use I, and I hate it. Please don't ever use I. That's terrible. If other people tell you they like it, fine. But I despise using I here because what it is the index. Now I can say scores at index. Right, use that list notation, say scores at index, and now I can add the score adjustment here. So this, if you access the value by index, you can change it. So we can add that score adjustment in. Now we'll see that it actually bumps some scores. All right, let's guess our number again. I probably should have taken this out because, you know, it's entertaining for me. I don't know how entertaining it is for you. 79, too high, 77, 76. Okay, we guessed it. So we'll enter some scores. We'll do like 92, we'll do an 85, we'll do a 78, and how about a 91? And that's fine, we'll stop there. So the high is a 92, we should get 8 points to each of our scores. Enter some gibberish. So here were the originals, and this should be each of those plus 8. Plus 8, plus 8, plus 8, plus 8, looks good. High score was 92, low score was 78. We adjust. We can calculate it again if we want to copy paste some code and feel bad about ourselves, but that's fine. Right, so that's our option here using that range here. So you get add values by index and you can change them. So range gives you 0 up to but not including the value you give it. So if you just want to play with range, you can say like print range of 100. Yeah, let's actually do that at the top because we want to do that beforehand, right? So print range of 100. Nope. That didn't work, sorry. So, I don't know, values equals range of 100. We'll print the values. That's not what I was expecting. Run it again. Nope. Wow. Still didn't know what we wanted. Range 100. Why didn't that do it? Oh, so it's not... Range is not really a list. I was expecting it to look like a list. Now I'm feeling bad because that didn't work. Let's say for value in values. Right here, we'll just range here. So for value in range 100, we'll cheat. Print value. There we go. That's probably easier. So you can iterate over it, but it's not actually a list. And we see, oh, here's all of our values. So one value at a time, right? One item in collection. So range is a collection, but it's not a list, so it doesn't print like a list, like I was hoping. We'll just, we'll change that down to like 10. I'll stick this back down at the bottom for you for later, in case you want to see it. Oops, we'll put it a little lower. Watch Python print 0 to 9. And we'll do that. Sure. Just make sure it works. So 50, 75, 67, 62, 57, 60, too high, 59. All right, we guessed it. So 1, 2, 3, 4, 5 for some scores. That's a low average score, but it's going to get bumped up, right? Makes it almost perfect. And here, we've written 0 to 9. Hooray. So range is super handy. You're definitely going to want to use that in practice. So determining when you want a while loop or a for loop, really for loops are good when you have collections. When you have a list or a tuple or even a string, if you want to go over that, you can range over you can do a for list for dictionaries, but all you're going to get out is the keys, which is okay, right? So if you have some, gradebook is a dictionary, right? That's the curly braces here, and we'd say, I don't know, Eric has a score of 100 because I'm awesome, and then maybe we have Bobby has a score of 100 because Bobby's awesome, and then we have Sue, and Sue has a score of 100 because she's awesome, and then we've got John. Poor John, he's not doing so well. He's only got a 90. Sure, something like that. So we can say for key in gradebook. Again, this is just an item here. I'm calling it key because that's what it is. I can print. We're going to say here's a formatted string. So we'll say key has a score of, and then we want to say my dictionary key of that key value. Right? This will loop over each key at a time, and I can get the value associated with that key out of it here this way. So for key in gradebook, let's print it out. Oh man, I gotta guess all these numbers again. I forgot I could cheat and just enter too low. -1, ASDF. Cool, so Eric's got 100, Bobby's got 100, Sue's got 100, Johnny's got 90. For key in gradebook. Right, that gives you the keys out. Okay. We'll come back to nested loops, break, continue, loop else. What we can do of these, save those for Thursday here. Again, sorry, it's probably a little quicker than it would have been if we were actually talking in person. This dice is really fun. We're actually going to work on something similar to this for our lab exercise because dice are a lot of fun. But here's some examples. Let me make sure I go push that code out here. So here's chapter 5 loops, part 1. Push that out. Yeah, that's all I've got for right now. Oh, I've got a joke for you before we finish, because why not, right? We have to have all of our jokes. Where is it here? My friend just sent this one to me. Everyone knows I love telling dad jokes, so they always send them to me here. Where is it? Where is it? Where is it? Oh yeah, here we go. So it says, my bank called to let me know I had an outstanding balance. I said, thanks, I used to do gymnastics, and hung up. That was so nice of them to say. All right, you guys take care. We'll see you, or I'll have another video for Thursday.